Hey everyone, and welcome to another episode of my Help with Math Homework series. We're up to episode 6, and today we're going to be looking over one of those nasty binomial coefficient identity questions. Okay, so make sure to stick to the end, as I'm going to show you how easy it is to do these questions, and this is probably going to be the best tutorial. So let's get started. Firstly, I'd really appreciate if you'd help support the channel by subscribing and turning on those bell notifications so you know when my super high quality videos are released every Monday, Wednesday and Friday. Okay, let's help grow this to be the best maths channel on YouTube. Alright, let's get started. Okay, so our homework question is to prove the identity NC0, NC1 plus NC1, NC2 plus NC2, NC3 plus NCn minus 1, NCn equals 2n factorial over n plus 1 factorial, n minus 1 factorial, which you can see here. What a mouthful to say. But they said by comparing the coefficients of x to the power of n plus 1 on the left hand side and right hand side of the identity, 1 plus x to the power of n times 1 plus x to the power of n equals 1 plus x to the power of 2n. Okay, whew, that was a mouthful to say. So the first thing we need to know is, since we're comparing coefficients, we need to know that nck is the coefficient of x to the power of k in the expansion 1 plus x to the power of n. And 2nck is the coefficient of x to the power of k in the expansion 1 plus x to the power of 2n. Also, when we multiply coefficients together, we get that nck times ncr is the coefficient of x to the power of k plus r. Alright, so that means when we have two coefficients together, you'll see here, to get the power, you just add those little numbers at the bottom, k and r, and that's the coefficient of that power of x. So now if we go back to the original question, the left hand side of the identity has to be the coefficient of x to the power of n plus 1 in 1 plus x to the n times 1 plus x to the n, and the right hand side is obviously the coefficient of x to the power of n plus 1 on the right hand side. Now the left hand side looks messy, which is what the trick here is, but the right hand side is a single term, and if we go to what I said before, that 2nck is the coefficient of x to the k in 1 plus x to the power of 2n, then we get 2ncn plus 1 as the coefficient of x to the n plus 1. So then if we use the identity that nck equals n factorial over k factorial brackets n minus k factorial, we can get the right hand side of the actual question straight away. Now here's the tricky part. To get the left hand side, we need to dissect it. Okay, so first off, if we look at the numbers at the bottom, we have the 0 and the 1. Now if we go to what I said before, is when we times the coefficients together, to get the power of x, you add those two numbers at the bottom. But if we add 0 and 1, it gives us 1, which is the coefficient of x and not x to the n plus 1. And if we do the next one, 1 and 2 will give us 3, which is not n plus 1. So currently the left hand side does not look like the coefficient of x to the n plus 1. So here's the trick that they love to use, and it's the symmetry of coefficients identity. But nck equals ncn minus k. Right, because coefficients on either end of binomial theorem are equal. So if we apply that identity to the first part of each of those terms, it will turn into ncn, nc1, ncn minus 1, nc2, ncn minus 2, nc3 plus nc1, ncn. And now you'll notice all those numbers add up to n plus 1. So we just have to explain why that is the coefficient of x to the n plus 1 on the LHS, and we are done. Now in order to do this, we go back and we look. So 1 plus x to the power of n. So all the possible powers of x range from 0 up to n. So we need to find every combination that would add to n plus 1, which means we have to start at 1, right? Because 0 and plus n, which is the highest number, will not add to n plus 1. So we start at 1, then that goes with n. Then we go to 2, that will be n minus 1. We go 3, n minus 2, all the way up to n and 1. So those are our pairs that will add to give xn plus 1. So now we just state coefficient of x to the n plus 1 on the LHS is nc1 times ncn plus nc2 times ncn minus 1 and etc. plus dot dot all the way up to ncn times nc1. So we can state that that's true. We know that that is the coefficient of x to the n plus 1 on the LHS. Now in order to get it back to the actual identity in the question, we use the symmetry identity nck equals nc n minus k. And then that proves the left hand side. And hence we can just state, therefore LHS equals RHS and we are done. So you can see the trick to these questions is to just dissect the answer and get it back to something that looks familiar. Right? And as I said, they love the symmetry of coefficients identity. Pretty much that's it. So I hope whoever's question this was, this helps and that you found this tutorial on binomial coefficient identities helpful. This has been another episode of Help with Maths Homework. If you want to get your questions featured here, then just join my free Maths Help group on Facebook, post your questions there and they just might be featured. If you learned something today, then make sure to subscribe, turn on those bell notifications, smash that like button, comment your thoughts below and share this video so everyone can learn. I'll see you next episode.